Welcome back. In this session, we discuss Stokes theorem, which says that the circulation of vector field F around the boundary C of an oriented surface S in the direction counterclockwise with respect to the surface unit normal vector n equals the integral of del cross F dot n over S. Surface integrals. We now show how to integrate a function over a surface. Definition. If R is the shadow region of a surface S defined by the equation f of xyz is equal to C and G is a continuous function defined at the points of S, then the integral of G over S is the integral double integral over R G of xyz determinant del f by determinant del f dot p dA, where P is a unit vector normal to R and del f dot P not equal to 0. The integral itself is called a surface integral. The surface area differential and the differential form for surface integral. Surface area differential is ds is equal to determinant del f by determinant del f dot P dA. And differential formula for surface integral is double integral over S G ds. Hence, double integral over S G ds is equal to double integral over R G of xyz determinant del f by determinant del f dot P dA. We also recall the following surface integral formula. Double integral over S f dot n ds is equal to double integral over R f dot n dx dy by determinant n dot k, where R is the orthogonal projection of S on the xy plane. Double integral over S f dot n ds is equal to double integral over R1 f dot n dy dz by determinant n dot I, where R1 is the projection of S on yz plane. Double integral over S f dot n ds is equal to double integral over R2 f dot n dz dx by determinant n dot j, where R2 is the projection of S on zx plane. Stokes theorem. Now we state Stokes theorem. Stokes theorem. The surface integral of the normal component of the curl of the vector field F taken over a bounded surface S equals the line integral of the tangential component of the vector F taken over the closed curve C bounding the surface S, that is double integral over S del cross F dot n ds is equal to circulation over C F dot dr, where n is a unit vector normal to the surface and F is a vector point function. Example 1. Verify Stokes theorem for F is equal to x square minus y square I plus 2xyj in the rectangular region in the xy plane. The vertices of the rectangle being given by 0, 0, a0, b0 and ab. Solution. Here the bounded surface S is the rectangle R given by R 0 less than or equal to x less than or equal to a, 0 less than or equal to y less than or equal to b. Given f is equal to x square minus y square I plus 2xyj. Therefore, del cross f is equal to determinant I j k dou by dou x dou by dou y dou by dou z x square minus y square 2xy 0, which is equal to I 0 minus j 0 plus k 4y, which is equal to 4yk. The surface is the rectangular region in the xy plane. Hence, the outward normal to the surface is k. Therefore, n ds is equal to k dx dy. Therefore, double integral over S del cross F dot S is equal to integral 0 to a integral 0 to b 4yk dot k dy dx. Double integral over 0 to a 0 to b 4y dy dx is equal to 2ab square, equation number 1. Now, circulation over C f dot dr is equal to integral over OA f dot dr plus integral over AC f dot dr plus integral over CB f dot dr plus integral over BO f dot dr, equation number 2. F dot dr is equal to x square minus y square I plus 2xyj dot dxi plus dyj plus dzk, which is equal to x square minus y square dx plus 2xy dy. 1. In OA, y is equal to 0, dy is equal to 0 and x varies from 0 to a. Integral over OA f dot dr is equal to integral 0 to a x square minus 0 square dx plus 2x into 0, which is equal to integral 0 to a x square dx, which is equal to 1 by 3 a cube. Similarly, integral over AC f dot dr is equal to integral over 0 to b 2ay dy is equal to ab square, since x is equal to a, dx is equal to 0. Integral over CB f dot dr is equal to integral over a to 0 x square minus b square dx, which is equal to minus integral 0 to a x square minus b square dx, which is equal to a b square minus 1 by 3 a cube, since y is equal to b, dy is equal to 0. Integral BO f dot dr is equal to 0, since x is equal to 0, dx is equal to 0. Using the above values, 2 becomes circulation over C f dot dr is equal to 1 by 3 a cube plus a b square minus 1 by 3 a cube, which is equal to 2ab square. Equation number 3. From 1 and 3 we get double integral over S del cross f dot n ds is equal to circulation over C f dot dr, so that Stokes theorem is verified. Example 2. Verify Stokes theorem for f is equal to 2x minus y I minus y z square j minus y square z k, where S is the upper half surface of the unit sphere, x square plus y square plus z square equal to 1 and C is its boundary. Solution. Del cross f is equal to determinant I j k dou by dou x dou by dou y dou by dou z 2x minus y z square minus y square z, which is equal to k on simplification. Therefore, double integral over S del cross f dot n ds is equal to double integral over R del cross f dot n dx dy by determinant n dot k, where R is the orthogonal projection of S on the xy plane. That is, R is the region enclosed by the circle x square plus y square equal to 1, which is equal to double integral over R k dot n dx dy by determinant n dot k, which is equal to double integral over R dx dy. Now, double integral over R dx dy is the area of the region enclosed by the circle x square plus y square equal to 1 and is pi into 1 square equal to pi. Hence, we obtain double integral over S del cross f dot n ds is equal to pi. Equation number 4. The boundary C of S is a circle in the xy plane of radius 1 and center at the origin. Suppose x is equal to cos t, y is equal to sin t, z is equal to 0, 0 less than or equal to t less than or equal to 2 pi be the parametric form of C, then circulation over C f dot dr is equal to circulation over C 2x minus y dx, since z is equal to 0, dz is equal to 0, which is equal to integral 0 to 2 pi 2 cos t minus sin t into minus sin t dt, since x is equal to cos t, dx is equal to minus sin t dt, which is equal to pi. Equation number 5. From 4 and 5, we get double integral over S del cross f dot n ds is equal to circulation over C f dot dr. Hence, Stokes theorem is verified. Example 3. Use Stokes theorem to evaluate double integral over S curl f dot n ds over the upper half of the hemisphere of radius a center at the origin if f is equal to 2yi minus xj plus zk. Solution. By Stokes theorem, double integral over S curl f dot n ds is equal to double integral over S del cross f dot n ds, which is equal to circulation over C f dot dr, where C is the boundary of S. Here boundary C of S is a circle in the xy plane of radius a and center at the origin. That is, C is the circle x square plus y square equal to a square. Now f dot dr is equal to 2yi minus xj plus zk dot dxi plus dyj plus dzk, which is equal to 2y dx minus x dy plus z dz. Along C, z is equal to 0, so that dz is equal to 0. Hence, circulation over C f dot dr is equal to circulation over C 2y dx minus circulation over C x dy. Suppose x is equal to a cos theta, y is equal to a sin theta are the parametric equations of the curve C. Then circulation over C f dot dr is equal to integral 0 to 2 pi 2a sin theta into minus a sin theta d theta minus integral 0 to 2 pi a cos theta into a cos theta d theta, which is equal to minus a square integral 0 to 2 pi 2 sin square theta plus cos square theta d theta, which is equal to minus 3 pi a square. Therefore, the required integral is given by double integral over S curl f dot n ds is equal to minus 3 pi a square. Example 4. Prove that integral over C r dot dr is equal to 0. Solution. By Stokes theorem, integral over C r dot dr is equal to double integral over S del cross r dot n ds, which is equal to 0, since curl r is equal to 0. Example 5. Evaluate circulation over C xy dx plus xy square dy by Stokes theorem, where C is the square in the xy plane with vertices 1 0, minus 1 0, 0 1, 0 minus 1. Solution. Here f dot dr is equal to xy dx plus xy square dy, so that f is equal to xyi plus xy square j, and hence del cross f is equal to determinant ijk dou by dou x dou by dou y dou by dou z xy square 0, which is equal to y square minus x into k. Also n is equal to k. Therefore, curl f dot n is equal to y square minus x k dot k, which is equal to y square minus x. Therefore, circulation over C xy dx plus xy square dy is equal to double integral over S del cross f dot n ds, which is equal to double integral over S y square minus x into dx dy, which is equal to integral minus 1 to 1 y square x minus 1 by 2 x square from minus 1 to 1 dy, which is equal to integral minus 1 to 1 2 y square dy, which is equal to 4 by 3. Example 4. Verify Stokes theorem. Given the hemisphere S x square plus y square plus h square is equal to 9, z greater than or equal to 0. Its bounding circle C x square plus y square equal to 9, z is equal to 0, and the field F is equal to yi minus xj. Solution. We calculate the counterclockwise circulation around C as viewed from above using the parametrization of the given circle r theta is equal to 3 cos theta I plus 3 sin theta j 0 less than or equal to theta less than or equal to 2 pi. Dr is equal to minus 3 sin theta d theta I plus 3 cos theta d theta j. F is equal to yi minus xj, which is equal to 3 sin theta I minus 3 cos theta j. F dot dr is equal to minus 9 sin square theta d theta minus 9 cos square theta d theta, which is equal to minus 9 d theta. Circulation over C f dot dr is equal to integral 0 to 2 pi minus 9 d theta, which is equal to minus 18 pi. Also, del cross f is equal to dou p by dou y minus dou n by dou z I plus dou m by dou z minus dou p by dou x j plus dou n by dou x minus dou m by dou y k, which is equal to 0 minus 0 I plus 0 minus 0 j plus minus 1 k, which is equal to minus 2k. N is equal to xi plus yj plus zk by square root of x square plus y square plus z square, which is equal to xi plus yj plus zk by 3 is the outer unit normal with f of xyz is equal to x square plus y square plus z square equal to 3 square. We take p is equal to k and calculate determinant del f is equal to determinant 2xi plus 2yj plus 2zk, which is equal to 2 into square root of x square plus y square plus z square is equal to 2 into 3, which is equal to 6. Determinant of del f dot p is equal to determinant del f dot k, which is equal to determinant 2z, which is equal to 2z. ds is equal to determinant del f by determinant del f dot p dA, which is equal to 3 by z dA. Del cross f dot n ds is equal to minus 2z by 3 into 3 by z dA, which is equal to minus 2 dA. Hence, the curl integral of f is double integral over s del cross f dot n ds is equal to double integral over x square plus y square less than or equal to 9 minus 2 dA, which is equal to minus 18 pi. Hence, Stokes theorem is verified. Example 6. A fluid of constant density delta rotates around the z axis with velocity v is equal to omega minus yi plus xj, where omega is a positive constant called the angular velocity of the rotation. If f is equal to delta v, find del cross f and relate it to the circulation density. Solution. With f is equal to delta v, which is equal to minus delta omega yi plus delta omega xj. Del cross f is equal to dou p by dou y minus dou n by dou z I plus dou m by dou z minus dou p by dou xj plus dou n by dou x minus dou m by dou y k, which is equal to 0 minus 0 I plus 0 minus 0 j plus delta omega minus delta omega k, which is equal to 2 delta omega k. By Stokes theorem, the circulation of f around a circle C of radius p bounding a disk S in a plane normal to del cross f, say the xy plane is circulation over C f dot dr is equal to double integral over S del cross f dot n ds, which is equal to double integral over S 2 delta omega k dot k dx dy, which is equal to 2 delta omega pi p square. Thus, del cross f dot k is equal to 2 delta omega, which is equal to 1 by pi p square circulation over C f dot dr. Equation number 6. Equation 6 relates del cross f with the circulation density. Example 7. Use Stokes theorem to evaluate integral over C f dot dr if f is equal to xz I plus xyj plus 3xzk and C is the boundary of the portion of the plane 2x plus y plus z is equal to 2 in the first octant traversed counterclockwise as viewed from above. Solution. The plane is the level surface f of xyz is equal to 2 of the function f of xyz is equal to 2x plus y plus z. The unit normal vector n is equal to del f by determinant del f is equal to 2i plus j plus k by determinant 2i plus j plus k, which is equal to 1 by root 6 into 2i plus j plus k is consistent with the counterclockwise motion around C. To apply Stokes theorem, we find curl f is equal to del cross f is equal to determinant I j k dou by dou x dou by dou y dou by dou z xz xy 3xz, which is equal to x minus 3z j plus yk. On the plane z is equal to 2 minus 2x minus y. So, del cross f is equal to x minus 3 into 2 minus 2x minus yj plus yk, which is equal to 7x plus 3y minus 6j plus yk, and del cross f dot n is equal to 1 by root 6 into 7x plus 3y minus 6 plus y, which is equal to 1 by root 6 into 7x plus 4y minus 6. The surface area element is d rho is equal to determinant del f by determinant del f dot k dA, which is equal to root 6 by 1 dx dy. Using Stokes theorem, the circulation over C f dot dr is equal to double integral over S del cross f dot n d rho, which is equal to integral 0 to 1 integral 0 to 2 minus 2x 1 by root 6 7x plus 4y minus 6 into root 6 dy dx, which is equal to integral 0 to 1 integral 0 to 2 minus 2x 7x plus 4y minus 6 dy dx, which is equal to minus 1. Now, let us conclude the session. In this unit, we have discussed surface integral and differential form for surface integral, also stated Stokes theorem. Before moving to the next session, please try to answer the following questions. Verify Stokes theorem for the following data. F is equal to x square plus y square I minus 2xyj taken around the rectangle bounded by the lines x is equal to plus or minus a, y is equal to 0 and y is equal to b. F is equal to yi plus 2xj plus 2k, and C is the circle x square plus y square equal to 1 in the xy plane, and S is the plane area bounded by C. F is equal to y square I plus xyj minus xzk on the upper half of the sphere x square plus y square plus z square equal to a square. F is equal to x square I plus xyj in the square region in the xy plane bounded by the lines x is equal to 0, y is equal to 0, x is equal to a, y is equal to a.